Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, in our lecture, I want to discuss Module 3. In first chapter, in Module 3, there is a topic, partial differential equation. Partial differential equations. And the first topic I am taking here of partial differential equations, that is first order and first degree Lagrange's linear partial differential equation. So here in this lecture I want to discuss about in detail Lagrange linear partial differential equations. Lagrange is the name of a famous mathematician who gave several research in mathematics. Search, we can say that a search, new idea, new equations, new derivations in a mathematics. So we can say that is a search, not research. So the very grateful involvement of famous mathematician Lagrange, and he gave a partial Lagrange linear partial differential equation of first order and first degree. So today I want to discuss about the method of Lagrange linear partial differential equation. So first of all, in partial differential equation, the name of the topic is first order Lagrange linear partial differential equation. So now we want to discuss about the definition of partial differential equation. What is definition? What is definition of a partial differential equation? In short form, partial differential equation represented by PDE. PDE, partial differential equation, partial differential equations represented by PDE. In short form, PDE, partial differential equation. Ordinary differential equation, ODE. We have discussed in last lectures what is ODE. ODE we have already discussed. ODE. ODE means ordinary differential equations. But in this module 3, we want to discuss about PDE, partial differential equation. So here we want to define how we can say that this is given differential equation is known as a PDE or ODE. How we can define, how we can differentiate in ODE and PDE. So definition of partial differential equation, definition 1. Several types we can define here. So now number 1, partial differential equations are those equations which contains partial derivatives. Independent of variables. Partial derivative, independent variables and dependent variables. A differential equation, we see that a differential equation which contains partial derivative. Partial derivative means partial derivative and independent variables and dependent variables are in an equation. That equation known as a partial differential equation. Now definition 2, we can define other way. in a differential equation in which only one dependent variable z. We see that in a differential equation there is only one independent variable z, one dependent variable z, and more than one independent variables x and y. Here we are taking only two variables x and y. X and y are independent variable and z is dependent variable on x and y. So here present in any differential equation there are only single dependent variable z and more than one independent variable x and y are present. Say here z is a some function of xy. Say z equal to function of x and function of y. So here we can differentiate of z with respect to x by as a constant. So we can write this here dou z over dou x. This is the differentiation of z with respect to x. And similarly again differentiating this 2 times dou 2z over dou x2. 2 times differential of z with respect to x by as a constant. This is the second order derivative of z with respect to x partially. This is partial derivative. This is the differential of z with respect to x partially. First order and first degree. First degree and second order derivative. Okay. So here y is a constant. When we are writing here del z, dou z over dou x. Here y constant and dou 2z over dou x2. This is y constant. 2 time differential with respect to x. Here 1 time differential with respect to x. Here y is a constant. Both derivative y keeping constant. Now del dou z over dou y. Differentiating that with respect to y. X as a constant. And dou z over dou y2. 2 time differential of z with respect to y. In both derivative x as a constant. So these are all derivative are known as a partial derivative, partial differentiation. Here more than one independent variable in z. And z is dependent variable on x and y. So if we differentiate with respect to x to z, then y keeping as a constant. And we differentiate z with respect to y, then x keeping as a constant. Means we differentiate with respect to x, then other r variable keeping constant. And we differentiate with respect to y, then other all variable keeping as a constant. So this differentiation is known as a partial differentiation. And these derivatives are known as a partial derivatives or partial differential coefficient. So here x and y are independent variables in our differential equation and z is dependent variable on x and y. Here z differentiate with respect to x and y partially. We want to differentiate here, we differentiate to the dependent variable z with respect to x and y partially. Partially means if we want to differentiate with respect to x, then other variables are constant. If we want to differentiate with respect to y, then other variables are constant. So this is the meaning of partial differentiation. Now, when z differentiate with respect to x, then y keeping as a constant, or z differentiate with respect to y, then keeping as a constant. Here is some basic points which are given in point 1 and 2. When z differentiate with respect to x, in point 2 we discuss here when z differentiate with respect to x, then y keeping as a constant, and or z differentiate with respect to y, then x keeping as a constant. So this differentiation is known as a partially differentiation. Now some basic notations in a differential equation in derivative form are given as below. All representation are in derivative form. Here, point 3. Partial derivative of z with respect to x means dou z over dou x. That is represented by capital dz. If we differentiate with respect to x, then we write capital D. Here, dou over dou x is capital D. Dou over dou x is equal to capital D. And dou over dou y is capital D dash. D dash dash represented by second variable y and D represented by first variable x. So dou over dou x is D and dou over dou y is D dash. So these are partial differentiation with respect to x and y, and this is the operator D. In partial differentiation, D represented by partial differentiation with respect to x, and D dash is partial differentiation with respect to y. This is the differential operator with respect to x and y. D and D dash are derivative, operator of derivative with respect to x and y respectively. D is respect to x and D dash respect to y. This is dash, D dash. So I am writing here some notations in a partial differential equation in derivative form is given here. So here dou z over dou y. Dou z over dou y means here z differentiate with respect to y. So we can write D dash z. Next, dou 2z over dou x over dou y. Dou 2z y dou x into dou y. So here 2 times differential of z with respect to x and y. So y represented D dash, x represented D. So we can write D dash z. This is equal to dou 2z over dou y dou x. Dou y and dou x. Order can be changed here. So we can write this D dash and D and z. Here dou over dou y is D dash. Now dou 2z over dou x2. 2 times differential of z with respect to x. 2 times differential of z. Partial derivative of z with respect to x 2 times. Dou 2z over dou x2. This is represented by D square z. And dou 2z over dou y2. 2 times differential of z with respect to y. This is the second order derivative of z with respect to y. Dou 2z over dou y2 is D dash square z. D dash dou 2z over dou y2. This is D dash square and z. Okay. This is the representation of all derivatives with respect to x and with respect to y. First order and second order in different notations are given here. So if you entering in partial differential equation, if you want to read a partial differential equation, then you understand these all notations carefully. Without understanding these notations, that is very difficult to learn a partial differential equation. So first of all, you remember point 3 is very important. Okay, all derivatives you know. What is dou z over dou x? Dou z over dou x means differential of z with respect to x. Here other variable y constant. That is represented by dz. D is differential operator partially with respect to x. And dou z over dou y. Dou z over dou y means differentiation of z with respect to y. Other variable are constant, means x constant here. So differentiation partially with respect to y, we write d dash z here. This is first order and first degree derivative. Now next, second order and first degree derivative with respect to x and y. So that is represented by d dash z or d dash dz. Both are same. Next, second order derivative with respect to x here. And second order derivative with respect to y here. So dou 2z over dou x2. This is d square z. Dou 2z over dou y2, this is d dash square z. This is dash d dash square z. Okay. Now, some other notations in a partial differential equation are also given below. These are very important notations. This point 4. Point 4 is very important point. So here, dou z over dou x. This is partial derivative of z with respect to x. Other variables are constant. Means y constant here. Here y constant. Y as a constant. This is represented by small p. Small p. This is represented by small p. And dou z over dou y. Here x as a constant. Partial derivative of with respect to y. X as a constant. This is represented by q. Then del dou 2z over dou x and dou y equal to dou 2z over dou y and dou x. This equal to represented is r. S. This is represented as. And next, dou 2z over dou x2. 2 times differential of z with respect to x here, 2 times. This is represented by r. And dou 2z over dou y2, 2 times differential of z with respect to y. This is represented by t. Okay. So these are all derivatives are very important, which are given in partial differential equation PDE in main form. So what is P, what is Q, what is R, what is S, what is T, P, Q, R, S, T. These are 5 elements in partial differential equation. There is most important role of these 5 elements P, Q, R, S, T. P, Q, R first order derivative and R, S, T are second order derivative. R is second order derivative with respect to x, T is second order derivative with respect to y, and S is second order derivative with respect to x and y both. Okay. So basically there are 5 elements, P element, Q element, S element, R and T. These are 5 elements are given in partial differential equations. Some examples of a partial differential equation of first order, first and second order and first degree are given as below. Here I am giving some examples. Some examples of first order and some examples of second order of partial differential equation PDE and first degree. Degree is 1. So here example 1 here. X is independent variable. Dou z over dou x. X dou z over dou x plus y dou z over dou y equal to z. This question can be write here x p plus y q equal to z. This is a example of partial differential equation of first order and first degree. This is the question of Lagrange differential equation. Now second example PP. Here capital P and small p plus capital Q and small q equal to r, where PQ are function of x. PQR are function of x here. Third example, dou z over dou x plus dou z over dou y equal to 1. This question can be write here p small p plus small q equal to 1. This is partial differential equation of first order and first degree. This differential equation and this differential equation known as a Lagrange linear partial differential equation of order 1 and degree 1. So these are basically these 3 examples of Lagrange differential equation of first order and first degree. General Lagrange differential equation is capital P and capital Q equal to R. This is general Lagrange differential equation. This is the first order and first degree differential equation. Now, some examples of second order and first degree partial differential equation are given below here. Here I am giving some examples of partial differential equation of second order and degree first order, second order and first degree. So here basically here dou 2z over dou x2 plus 5 dou 2z over dou x dou y plus 6 dou 2z over dou y2. This is homogeneous partial differential equation. Homogeneous partial differential equation with constant coefficient. The full name of this example, homogeneous partial differential equation of second order with constant coefficient. Okay, this is the example. Now second example, dou 2z over dou x2 plus 5 dou z over dou x dou y plus 6 dou z over dou y2 plus dou z over dou x plus 3 dou z over dou y. This is non-homogeneous partial differential equation of second order with constant coefficient. This is non-homogeneous. This is homogeneous. Each term have same order, two order. Here each term has not same order. Here is one order, here is one order, here is two order. So this is non-homogeneous. Non-homogeneous partial differential equation of second order with constant coefficient. This is homogeneous partial differential equation of second order with constant coefficient. This is also homogeneous partial differential equation of second order with constant coefficient. Now, method of forming, we want to discuss how we can forming a partial differential equation. If function is given, if equation is given, any equation is given to me, then how we can forming a partial differential equation with the help of given a relation. So method of forming a partial differential equations. A partial differential equation can be formed by two methods. Here we define here two methods. With the help of these two methods, we can form any partial differential equation with the help of given some relation. Okay. So method one is here, by eliminating arbitrary constant. Method one is by eliminating arbitrary constant in our given relation. Any relation given given in the question paper, and in this relation is some arbitrary constant and some variables. So now we want to eliminate our arbitrary constant. After eliminating arbitrary constant from the given relation, then we can form a partial differential equation from the given relation. Next one is method 2, by eliminating arbitrary function. We can eliminate either arbitrary constant if constant are given. Otherwise, we can eliminate a function if function is given in our relation. So there are two methods we can apply to forming a partial differential equation. Here we give some examples one by one method how we can form a partial differential equation with the help of given relation. A relation is given in our question. So now method 1. We discuss here method 1 by eliminating arbitrary constant. How we can eliminate a arbitrary constant which are given in our question. After eliminating the constant, then we get a partial equation, that is known as a forming of partial equation. So example 1 here, find the partial differential equation, PDE here, PDE. PDE means partial differential equation. So find the partial differential equation of all spheres whose center lie on z-axis. What is z-axis? Z-axis, there is only value of z, not value of x, not value of y. Means on any z-axis, coordinate is 0, 0 and z. 0, 0 and z. This is the z-axis. This is the coordinate on z-axis. So center lie on z-axis, and given y equation, this equation is given x square plus y square plus z minus a ka whole square equal to b square. This equation of sphere. This equation of sphere, this relation is given. This is the equation of sphere whose center is 0, 0, comma a, 0, comma 0, a, and radius is b. This is sphere. This relation is given on a sphere whose center lie on z-axis, and the coordinates of center is 0, comma 0, comma a, and radius is v, where a and v are constant. So here some relation is given to me in our question. That relation is x square plus y square plus z minus a ka whole square equal to b square. So this is the equation of sphere whose center lie on z-axis, whose centers are 0, comma 0, comma a, and radius is v, and a and v are constant here. So we want to eliminate a and v. We want to remove from relation 1 the arbitrary constant a and v. After removing a and v, we find the solution. We find a partial differential equation. So we start solution here. We have a relation x square plus y square plus z minus a ka whole square equal to b square. This equation 1 is given in a relation. This relation is given in our question. Here a and b are constant, x, y, z are variable. In our relation, x, y, z are variable, a and b are arbitrary constant. So any condition, we change the a and b. We remove the a and b from this relation. We want to eliminate the a and b from given relation 1. So equation contain two arbitrary constant a and b. Now, how we can eliminate b? So this is the procedure. With the help of this procedure, we can eliminate a and b. So you follow this procedure. Here now, differentiating 1 with respect to x partially. 1 means this relation 1. This relation 1 differentiating with respect to x partially by as a constant. Then we get, what we get here? 2x. How we differentiate? Differentiate with respect to x. X square plus y square plus z minus a ka whole square and equal to dou over dou x n into v square. Okay. So here dou over dou x differential of x square plus dou over dou x differential of y square plus dou over dou x differential of z minus a ka whole square equal to dou over dou x differential of v square. So now here is x square. Here is variable is x. So differentiation of x is with respect to x 2x plus differential of y square with respect to x. With respect to x by keeping as a constant. So here is 0 and plus differentiate z minus a. So this is 2 into z minus a and this is v is 0. So here 2x plus 2z minus a and equal to 0. We get this relation. Here differentiate del z over dou x also. So we get equation this 2x. This is the differentiation of x square and this is the 2z minus a ka whole square. 2z minus a dou z over dou x equal to 0. 2 cancel out. So here we get x plus z minus a. Dou z over dou x is p. We have already telling you p is dou z over dou x. So we write here p this equal to 0. This equation 2. Now differentiating with respect to differentiating one with respect to y. One means given relation. Again giving relation, differentiate with respect to y partially. Keeping x as a constant, then we get. So here differentiate same. Dou over dou y of x square first term plus dou over dou y square of second term plus dou over dou y z minus a ka whole square and equal to dou over dou y. This is v square. This is constant. So this result is 0. And this is 2z minus a dou z over dou y. And this is y. This result is 0. Differentiating of x square with respect to y is 0. Dou over dou y of x square. So this result is 0. Okay. So here we get 2y plus 2 into z minus a dou z over dou y equal to 0. This equation, now dou z, this is q. Q equal to dou z over dou y. We have already discussed about this element. Differential of z with respect to y, that is q. Dou z over dou y is q here. Now this value putting here, 2 each cancel. So y plus z minus a into q equal to 0. This equation 3. Next, finding value of z minus a from equation 2. Then we get, what is value of z minus a from equation 2? Equation 2 is this equation 2. Z minus a, what is value of z minus a? So z minus a is minus x taking this side, x taking this side and p divided by this. So minus this value is z minus a equal to minus x upon p. This equation 4. Putting in equation 3, then we get the value of z minus a. Z minus a is equal to minus x upon p, putting in 3. So what is 3? 3 is here y plus z minus a into q equal to 0. This equation 3. Now putting z minus a equal to minus x upon p. This value putting here. So y minus x upon p q equal to 0. This equation 5. Now simplifying this by p, multiply this here, cross multiply. This by p minus x q equal to 0, this equation 6. Okay. So this is partial differential equation. We can write this by dou z over dou x and minus x dou z over dou y equal to 0. This is partial differential equation. This is same as this. Both are same. So this is known as a Lagrange partial differential equation. This is forming. If given function is this, then we get this differential equation with the help of given relation. Now method 2. We are applying here method 2 by eliminating arbitrary function. If function in our question, function is given there, then we eliminate the function from our question and we get a differential equation, ordinary partial differential equation. Example 2 here, z equal to function x square minus y square. Solution, we have here z equal to, this relation we have, z equal to function x square minus y square. This equation 1. Function of f of x square minus y square. This is function z equal to given here. So now differentiating 1, this relation is 1. Differentiating relation 1 with respect to x partially. Keeping y as a constant, then we get. So now differential of z with respect to x, dou z over dou x. Now differentiating of function, if we differentiate any function with respect to x or y, then we apply dash. Suppose dou over dou x of function x comma y. So this is the f dash xy. This is derivative. Dash represented the first time differential with respect to x or y. So here we differentiate this f dash x square minus y square. Again differentiating inside function. inside function x square minus y square with respect to x, then we get 2x, y is 0. Okay. So here we differentiate with respect to x, dou over dou x, f x square minus y square. So we get here answer f dash x square minus y square, and dou over dou x of x square minus y square. So we get here f dash x square minus y square, and this x square is 2x and this y square is 0. So we get this answer. This is equation 2. Differentiating 1 with respect to y partially, keeping x as a constant. Now again we differentiate equation 1 with respect to y, x as a constant. Then we get result this. Dou z over dou y, this equal to q. This is known as a q. This is f dash x square minus y square. F dash means function is given here, so we apply dash. X square minus y square same as. Now again differentiating inside bracket with respect to y. So x is 0 and y square is minus 2y. Minus y square here, so minus 2y here. Z equal to here function x square minus y square. Now differentiating with respect to y. Okay. So here dou z over dou y. This equal to dou over dou y of f x square minus y square. Clear? So here differentiate of this function. Then we write here f dash x square minus y square. Now dou over dou y. Differentiation of x square minus y square. So this f dash x square minus y square. And here in bracket dou over dou y of x square and dou over dou y of y square. So this result is 0. This result is minus 2y. So we write here f dash x square minus y square into minus 2y. This result is 0. Clear? So this is the derivative of given function with respect to y. So we write here dou z over dou y equal to q equal to f dash x square minus y square into minus 2y. This is equation 3. Now dividing equation 2 by equation 3, then we get. What is equation 2? Equation 2 is this. This is P. Equation 3 is Q in left hand side. So P divided by Q. P upon Q here. And equation 2 is function dash f dash of x square minus y square into 2x. This in equation 2. Equation 3 is function dash f dash to x square minus y square into minus 2y. So dividing by f dash x square minus y square into 2x and f dash x square minus y square into minus 2y. This function cancel to this. Okay. So here 2 is cancel to this. This equal to minus x upon y. So now cross multiply here. Here is cross multiply. P upon Q equal to minus x upon y. This is cross multiply. This equal to Py equal to minus xq. This is Py plus qx equal to 0. So this is answer. Py plus qx equal to 0. We get the partial differential equation. This is the forming of partial differential equation with the help of given any relation or any function. If function is given, then we eliminate the function. If constants are given, then we eliminate the arbitrary constant. Now method 1. In next question again we apply method 1. Why eliminating arbitrary constant in this next question? This is problem 3. Z equal to x plus a in bracket into y plus v in next bracket. This is the relation. This relation is given in our question. Here a and b are arbitrary constant and x, y, z are variable. X, y, z are variables here. A and b are arbitrary constant. So in this given relation, we want to eliminate a and b. After eliminating a and b, we find a partial differential equation. So solution start here. Z equal to x plus a into x y plus b. This equation 1 is given in our question paper. So now differentiating 1 with respect to x partially, keeping y as a constant. So here z equal to x plus a into x plus y plus b. X plus a into y plus b. Now differentiating with respect to x to this. So dou z over dou x and dou z over dou x. Dou over dou x of x plus a. And this y is constant. This is in multiply. So multiply, this is in multiply constant, same as. Differentiation of this is 1. So y plus b only. Dou z over dou x is y plus b. This is equation 2. From equation 2, we find value of v. Then we have b. We finding this b. So by subtracting this. So b is equal to dou z over dou x minus y. Or we can write is b minus equal to p. This is p. P minus y. Okay. Now differentiating 1 with respect to y. Again given relation, differentiate with respect to y partially, keeping x as a constant. So dou z over dou y, this x plus a. So here again dou z over dou y equal to dou over dou y, x plus a and y plus b. So this is this is variable of x in multiply. So this is taking out x plus a and dou over dou y of y plus b, and this is 1. With respect to y, b is constant, this is 1. So this is x plus a, and this is q. So dou z over dou y equal to x plus a, or this implied that q equal to x plus a, or we find a. This is a equal to q minus x. Okay. Now this is a is this. So this implied that a equal to q minus x. This is value of q. Dou z over dou x, dou y is q, and dou z over dou x is, this is p. Putting the value of a and b from equation 3 and equation 5. This equation 5 and last equation is 3. In equation 1 means given relation, then we get this. Putting the value of a plus b. So z equal to x plus a, this is the value of a, and y plus b, this is the value of b. So now this x cancel to this y cancel to this. We get dou z over dou x and dou z over dou y. Dou z by dou x, dou z over dou y. So this is p and this is q. And this is z equal to. So z equal to p into q. This is partial differential equation. This is required PDE, partial differential equation. Our given relation is z equal to x plus a and into x plus b. This is relation y plus b. This relation is given. With the help of this relation, we convert this equation. Now method 2 again apply by eliminating arbitrary function. Arbitrary function. Arbitrary, not function, arbitrary constant here. Constant. This question is arbitrary constant, not function. So here question is example 4. This is last example. Ax square plus by square plus z square equal to 1. Here a, b are arbitrary constant. X, y, z are function. Here a, b are arbitrary constant. Arbitrary constant. And x, y, z are variable. X, y, z are variables. Okay. So now we want to eliminate the constant a and b from given relation. After eliminating a and b, we get the partial differential equation PDE. So solution start here. We writing the relation here, that is 1. Ax square plus by square plus z square minus 1. This is equation 1 here, equal to 0. Differentiating 1 with respect to x, partially keeping y as a constant, then we get here. So differentiation of this one, dou over dou x of ax square plus by square plus z square minus 1, this equal to 0. So differentiation of dou over dou x, ax square plus dou over dou x, by square plus dou over dou x, z square equal to 0. Minus 1, 1 is constant, so 0. So this is x here, 2ax plus this result 0 plus 2z and dou z over dou x. This equal to 0. So 2 is cancel this. So ax plus z dou z over dou x equal to 0. So we get this is p. Ax plus pz equal to 0. We get this equation. So here 2ax plus 2 dou z over dou x equal to 0. Here also z. 2z. So a2 is cancel this. Ax plus z, this is p. Zp equal to 0. We find out value of a here. So a equal to minus z upon x p. This equation 4. This equation 4 is value of a. Now differentiating 1 with respect to y, partially keeping x as a constant. So now we want to differentiate with respect to y to given relation. So dou over dou y, here is ax square plus by square plus z square minus 1 equal to 0. So now dou over dou y, here ax square plus dou over dou y, here y square plus dou over dou z, here z square, minus 1 is 0, so 0. So now this differential is 0. Here is function is x, differentiation with respect to y. So this result is 0. X is constant with respect to y. Plus here 2y. Here is b. Plus here is b. So 2by. Plus here 2z. Dou z over 2z. Dou z over dou y. Here is y. Not x. Here is y. So this equal to 0. 2 is cancel by v plus z. This is q. This equal to 0. Now finding the value of b. b equal to minus zq upon y. This is value of b. b is this from equation 7. Differentiating 1 with respect to y, keeping x as a constant, then we get here 2y plus 2z dou z over dou y equal to 0. Here 2by. 2by. So 2 is cancel here. So by plus zq equal to 0. This divided by y here, b equal to minus z upon yq. This is equation 7. From equation 1 we have this relation. Okay. Now z square taking this side, putting value of a from equation 4 and value of b from equation 7 in equation 8, then we get equation 8 is this. In this equation, putting value of a and b. So we get here minus z upon x px square minus z upon y qy square equal to minus common z square minus 1. This equation 9. Minus is cancel out. Multiply by minus. Minus cancel out on both sides. Then we get z upon x px square z upon y qy square equal to z square minus 1. This equation 10. 1y is 1y cancel. 1x is cancel. Z is common here. So here z common. Px plus qy equal to z square minus 1. This is required differential equation. This is required PDE, partial differential equation, which is formed by given relation. After eliminating a and b. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.